I'm Mrs. E. So glad you joined me today for another lesson in reading. Let's get started. The informational text that we will work with today is the macaws. You'll need materials like something to write on, something to write with. Feel free to pause the video so you can go get your materials. The learning target is I will learn to use RACE strategy to answer text evidence questions. And our success criteria is I can answer the question, why are macaws endangered, by using the RACE strategy. Here's our RACE strategy, and you may have seen this strategy before. Once again, it's an acronym, RACE. And R stands for restate the question. When we are given a question to answer based on text, we are going to first restate the question. And then the A stands for answer the question. So going back and seeing what is being asked, and make sure you include all parts of the question in your answer. And C stands for cite the source and tell where you found the examples and details in the text. And E stands for explain what it means, explain your response. Once again, restate the question, answer the question, cite the text evidence, and explain what it means. When you're citing the text or to cite the text, you could use sentence stems like this. The text states, or in the book, blank, on the page, blank, it states, and then you see these quotation marks around these. That's to say so that you could put exactly what the text says. So quotation marks, which are these marks right here, they indicate that the phrase or the sentence that you are using in the marks are taken from a source. And also to cite, it means to quote as evidence. Feel free to pause the video and write these sentence stems in the green. And then for letter E, to explain what it means, here are some sentence stems. I can infer that. This is because. This means. This shows. These are some of the examples that you can use to explain what it means. So go ahead and feel free to write these down. Our task today is to read the section in the book, How Are Macaws Doing? Then we are going to answer the question, why are macaws endangered? And we want to be sure to give evidence from the text. Let's read in our informational text, the book Macaws. We will read in this section, How Are Macaws Doing? Page 25. How are macaws doing? All macaw species are either threatened or endangered. This means they are in danger of becoming extinct. The red Cuban macaw is already extinct. The glaucous macaw may also be extinct. People are one of the biggest dangers to macaws. They cut down trees in the rainforest to raise and feed cattle. The macaws need these trees for nesting, for finding food, and for sleeping. Other people use colorful macaw feathers to make special clothing. These macaws are endangered because of the loss of their rainforest habitat. Protecting macaws. Some people also take young macaws from their nests and sell them as pets. Macaws taken from the wild do not make good pets. Many die when they are moved from their habitat. A habitat is a place where an animal or plant usually lives. Macaws taken from their natural home can easily catch diseases or die from the change. Today, laws protect wild macaws. It is against the law to take these birds from their habitats. Scientists have made macaw refuges. Refuge is a place where animals are protected. Macaws are safe in their refuges. When macaws in a refuge lose their feathers, scientists collect them. They give the feathers to people who use them for clothing. That way, people do not take macaws from the wild. Many people understand that macaws are important to life in the rainforest. They must teach other people what they know. Together, people of all ages can help keep macaws alive in their rainforest homes for a very long time. Macaws will die without rainforest trees to live in. Let's take a look at some of the vocabulary words in this text. We learned the word endangered. Endangered means that they are in danger of becoming extinct. And endangered, it also means in danger of dying out. And extinct is a species that has died out. And in here, they had talked about wild macaws, or macaws that are taken from the wild. What does the word wild mean? And a wild could refer to a natural home or environment or the wilderness. So wild would be where their natural home is. We also see the word refuge. A refuge is a place where animals are protected. And another word that we learned in here was species. A species is a group of animals or plants that are closely related to each other. See here, all macaw species are either threatened or endangered. Species referring to a group of animals or plants that are closely related to each other. Our task is to answer the question, why are macaws endangered? We are going to find evidence from our text to answer the question. So in here, I am finding that the people are cutting down trees, and that is causing the macaws to lose their habitat and they can't survive. So I'm going to first use my R in the race strategy where I am going to restate the question. So I'm going to have to turn this question into a statement. So I will take macaws are endangered. So I'm going to write macaws are endangered. Now I'll write the word because my question is asking why, and I'm going to give the reason. Because I'm going to talk about how they are losing their rainforest habitat. They're losing their homes. So I see that I have restated my question. I have also answered the question by saying that they are losing their rainforest habitat. Then my next part of this race strategy is I need to cite the text evidence to show that I found the answer in the text. So what I'm going to state is I found this evidence right here in this paragraph. So I'm going to use where I'm going to cite the text. I'm going to use this sentence stem right here in the book. On the page, it states, I'm going to put quotation mark around it and state what it says in the text. So I will write in the book. Macaws, I'm going to write it with capital M because it's the title of the book. Macaws, and I can also underline it because it's the title of the book. Macaws and it's on page 25. And then I will write its date. In other words, it says, comma, and then I'm going to put it in quotation marks because I'm going to take it right out of the book. It states, they cut down the tree, meaning the people, cut down trees in the rainforest to raise and feed cattle. Then I'm going to, what I need to do next is I need to explain what that quote means. So I think I'm going to use like this means, or I believe that, this is because, or I can infer that. So I'll use one of those sentence stems here. So maybe I'll say I can infer, I can draw a conclusion that they are losing their homes because people are cutting down the trees. And I'm going to further explain this. And I'll say macaws need these trees or their habitat for nesting. And I'm getting this right out of here. They need it for nesting, for finding food, and for sleeping. I could even summarize this and add another sentence here. The trees are important for macaws to survive. I can go back and reread what I wrote here. Macaws are endangered because they are losing their rainforest habitat. In the book, Macaws, on page 25, it states, they cut down trees in the rainforest to raise and feed cattle. I can infer that macaws are losing their homes because people are cutting down the trees. Macaws need these trees for nesting, for finding food, and for sleeping. These trees are important for macaws to survive. I can go back to make sure that I had used the race strategy to help me answer this question using text evidence. Restate the question. Macaws are endangered because, so yes, I did use the race. Restate the question. Answer the question. Did I answer the question? Macaws are endangered because they are losing. So yes, I did use the A in the race. Answer the question. Then did I cite the text? And I did right here in the book Macaws on page 25. Then down here, did I explain what it means? And I did do that by I can infer that macaws are losing their homes because people are cutting down the trees. And I did use my U here in the race. So I did use my race strategy. I also want to share with you the last part of this book that we've been working in, and it is this last part, and it does mention this in the table of contents, photo diagram, which is page 28. And in this diagram, remember a photo, here's a photo, but this is a diagram because it's showing me all the different parts and what they are called. So we've got the eyes, powerful beak, feet and claws, and colorful feathers, and long tail. And notice that it also gives me page numbers. So if I want to learn more about the eyes, then I can go to that page to learn more about that. Well, let's go back and revisit our learning targets, see how we did. I will learn to use race strategy to answer text evidence questions. Our success criteria was, I can answer the question, why are macaws endangered? By using the race strategy. Well, let's see how do we do? So did we read the text? Did we answer the question by restating the question? Did we answer the question by citing the text? Did we explain what it means? Great work today. I'm so proud of you. And keep reading. And don't forget, reading is awesome. On rainforest. So you can go to your Launchpad for Learning. Then you would look for the icon that says Mayan. Click on Mayan. Then it'll take you to this website. Then you will go to the library tab and then go ahead and click on search. Then in the search, you will type in rainforest. Then it gives you a nice variety of books that you can read online. And so let's say I want to read more about endangered rainforest. And you can see right here, as you click on this book, then click on info, it'll give you an overview of what that book is about. So let's go and take a look at this book, for example, The Endangered Rainforest. Then I can continue in the book. I can see right here, I can flip through these pages. Here's my title of the book. Then I'm going to go through the book. There's chapters here. And also there's other pages, meaning I can go to table of contents. Remember, these are the text features that we talked about. So I can go to table of contents to see what's in the book. As well as there's a glossary that I can click on, which is at the back of this book. It gives me a list of words that I can learn. And if I want to read more on this topic, it's going to give me other sources here in the book that I can read. So I'm going to go to table of contents and I'm going to start with chapter 1. And as I am reading this book, I can also, remember, I can take notes using this journal. So I can pull up my journal and write in here. I can take notes as I am reading.
Welcome to 5th grade mathematics. I am Mrs. Gooch of Mark Twain Elementary. Last time, we used what we know about place value to add and subtract decimal fractions. Today, we will also use our knowledge of place value and what we know about multiplying and dividing fractions to multiply and divide decimal fractions. Let's read our learning target together. Ready? Begin. I will multiply and divide decimal fractions. Fractions, of course, are equal parts of a whole, like 1/4 or 1/3 or 2/6. Decimal fractions are when we are using fractions of 1/10 or 100 or 1,000, etc., but we write them differently. Here we have two decimal fractions, 3/10 and 2/10, and we are multiplying them together. Here on our model, we see what happens when we multiply something by a fraction. This amount, 3/10 of a whole, is being multiplied by 2/10. This little square, or rectangle rather, up here is 2/10 of this amount that is pink. 3/10 times 2/10 equals 6/100. Remember, you multiply across the top and bottom, the numerator and the denominator, and you come up with an amount that is even smaller than the amount you started with. Let's read our success criteria together. Ready? Begin. I can use fraction notation and place value to solve a multiplication or division problem involving decimals. Here is a place value table. I want you to notice something about these two amounts. They both use the same digit, 2. But in the top example, the 2 is in the 1/10 place, or 2/10. In the bottom example, the 2 is in the hundredths column, so it is 2/100. Over here, I've used fraction notation. 2/10 times 1/10 is the same thing as 2/100. In other words, if you multiply this amount by 1/10, it moves to the smaller place value on the right. Remember the way place value works. If you multiply by 10, you go up to the bigger place value on the left. But if you divide by 10, you go to the right and the number is in the smaller place value. Multiplying by 1/10 is the same thing as dividing by 10, because remember, 2 times 1 is 2, 10 times 10 is 100. 2/10 times 1/10 is 2/100. Just like place value we knew before, the place value that includes decimal fractions works the same way. Every place value to the left is 10 times bigger. Place value to the right is 10 times smaller. We will use this property of place value to solve multiplication and division problems. Let's look at an example of how decimals are used in real life. Francisco buys 3 5/10 of a gallon of gas and pays $2.30 per gallon. Remember, this is the same thing as saying 2 30/100 of a dollar. So $2.30 of a dollar, or 30 cents. How much does he spend? The first thing we ask is what is happening in this problem. Francisco is buying gas for his sporty red car. So we know he is buying gas, but what is the problem asking us to figure out? Francisco buys 3 5/10 gallon of gas and pays $2.30 per gallon. How much does he spend? The question at the end is asking how much he is spending. What information do we need to find out how much he is spending? And what math are we going to need to do? Looking carefully, we see two different amounts. We see how much gas he's buying altogether, 3 and 5/10 of a gallon. GAL stands for gallon. And what does this mean here? Per. $2.30 per gallon. That means 1 gallon of gas costs $2.30. But is Francisco buying 1 gallon of gas? How many gallons of gas is he buying? 3.5, or 3 and 5/10. So we need to find out how much he spends if each single gallon, one whole gallon, costs $2.30. How much is 3 and 5/10 of a gallon? 3 and 5/10 gallons. We will need to multiply. What numbers are we working with? 3 and 5/10, $2.30, or 2 and 30/100. Let's write the equation. 3 and 5/10 times 2 and 30/100. Let's use M to stand for our unknown, the amount of money he's going to spend in dollars and cents. 3 and 5/10. We can write this in fraction notation. And we can write 2 and 30/100 in fraction notation too. We can use what we know about multiplying fractions now to solve this equation. How many tenths are in 3 wholes? 30. So 30 tenths plus 5/10 will make 35 tenths. How many hundredths are in 2 wholes? 200 plus 30 hundredths makes 230 hundredths. Now we can multiply across the numerator and across the denominator. The numerator will be whatever 35 times 230 is, and the denominator will be 10 times 100, or 1,000. So this amount, which, by the way, it's the same as our original equation, but without the decimal points, is being divided by 1,000, or multiplied by 1/1000th. Interesting. Let's do this part using the standard American algorithm. 230 times 35. Notice how they're lined up by place value. Very important. Oops. 5 times 0 is 0. 5 times 3 is 15. Notice how I regrouped. 5 times 2 is 10. Plus 1 is 11. Now to get the other partial product, erase the regroup. 3 times 0 is 0. Oh, almost forgot to put my placeholder. Is 0. 3 times 3 is 9. 3 times 2 is 6. And I add these together. 0 plus 0, 5 plus 0, 1 plus 9 is 10. Let's regroup. 1 plus 1 plus 6 is 8. I get 8,050. Remember that this amount is this up here, and it's being multiplied by 1/1000th, or divided by 1,000th. If we multiply this by 1/1000, we get 8,000 50 thousandth. If we write this in decimal notation, 1 tenths, hundredths, thousandths, we would start by putting the 0 in the thousandths, the 5 in the hundredths, the 0 in the tenths, and the 8 in the ones. And we get 8 and 5 hundredths. We can ignore that 0. So the amount he pays is $8.05. M equals $8.05. Our sentence will read, Francisco spent $8.05 on gas. Let's try one more problem. Alma's pasta recipe uses 1 25 hundredths of a pound of pasta. She has 8 75 hundredths of a pound of pasta in the pantry. How many times can she make her pasta recipe? We know Alma is making pasta. Every time she makes pasta, she takes this amount out of this amount. These are the two numbers we are working with. We want to know how many times can she take this amount out of this amount. That's division. We are dividing the amount she has in the pantry by the amount she takes out for each recipe. Let's use the letter P for pasta. If 8 75 hundredths divided by 1 25 hundredths equal P, that also means that 1 25 hundredths times P equals 8 75 hundredths. So we can kind of think about and guess how many times 1 25 hundredths goes into 8 75 hundredths. I could try rounding. 1.25 is really close to 1. And 8 75 hundredths, well, that's close to 9. So P might equal 9. 1 times 9 is 9. I'm wondering if that's a little big, because if I multiply 1 by 9, I've already got more than 8 75 hundredths. I've got 9. So 9's going to be too big. What about 8? If I multiply 1 by 8, I'll get 8. But what about 25 hundredths times 8? I know 4 times 25 hundredths is 1. So 8 times 25 hundredths would be 2. If I've already got 8, that'll give me 10. 8's too big too. Let's try 7. So we are wondering what 1 25 hundredths times 7 equals. In order to do this, we can look at the whole number part and the fraction part separately. This is the same thing as 100th times 125. Remember, 100th as much means moving the decimal point 2 times to the left, making it smaller, times 7. So I've broken 1 25 tenths up into these two factors. Now I can associate these two factors and then multiply that amount by 100th. Let's multiply 125 by 7. 7 times 5 is 35. 7 times 2 14 plus 3, 17. 7 times 1 is 7, plus 1 is 8. Ah, that looks promising. 875, 875. If we multiply it now by 100th, we get 8 and 75 hundredths. Remember how this works. Eight and 75 hundredths. 875 hundredths. This is the same as saying 8 and 75 hundredths, which is what we've got. So P equals 7, and Alma can make her recipe seven times. Meeting today's learning target and success criteria means that we are multiplying and dividing decimal fractions by remembering what we know about multiplying and dividing fractions and what we know about place value and how the place value of on the right is 10 times smaller. So if you multiply by 1/10, which is the same as dividing by 10, you are moving to the place value to the right. Keep on practicing and look for the math in everyday life.
Hola chicos, buenos días, buenas tardes, buenas noches. Vamos a seguir hablando de mate, obviamente. Esta vez vamos a hablar de cómo restar decimales, ¿ok? Hemos hablado de cómo sumar, vamos a hablar de cómo restar decimales y vamos a repasar el valor posicional de decimales hoy, ¿ok? Entonces, ten listo tu lápiz, tu cuaderno, un papel donde escribir, donde tomar notas y vamos a empezar con nuestra lección del día. De cómo restar decimales. Ya aprendimos cómo sumar. Ok, tenemos el primer problema aquí. La masa de un colibrí hembra es de 4 y 5 décimas o décimos gramos. Ok, aquí tenemos nuestra tabla de valor posicional. Te sugiero que te entras a Google, puedes buscar tabla de valor posicional con decimales y vas a poder encontrar algo así. Puedes imprimirlo, pegarlo en tu cuaderno, puedes tomar un screenshot de eso, pero eso es muy importante, ¿ok? Debe de tener algo así, ¿ok? Que puedes usar como referencia, ¿ok? Vamos a empezar con restar decimales. La masa de un colibrí hembra es de 4 y 5 décimos gramos. La masa de un colibrí macho es de 3 y 2 décimos gramos. ¿Cuál es la diferencia entre las masas de los colibríes hembra y macho? Okay. Los colibríes, tal vez tienen colibríes afuera de tu ventana. Okay. Vamos a ver, ¿cuál es el más grande? La masa de un colibrí macho, 3.2 gramos. Colibrí hembra, 4.5 gramos. ¿Okay? ¿Cuál es la diferencia? ¿Okay? Fíjense, chicos, estamos hablando de diferencias. Entonces, eso nos está diciendo que vamos a tener que restar. ¿Ok? Diferencia, restar. Muy bien. Pues hay varias maneras de hacer eso. Para mí lo más fácil es usar una tabla de valor posicional. Vamos a encontrar la diferencia entre los dos colibríes. Entonces voy a escribir primero mi número más grande. 4 y 5 décimos es más grande que 3 y 2 décimos. Entonces voy a escribirlo así. 4.5 menos 3.2, ¿ok? Y ya está, chicos. O sea, no hay nada más, ¿ok? Vamos a poner nuestra decimal aquí, misma posición, y luego nada más tenemos que restar 5 menos 2, 3, 4 menos 3, 1, ya. ¿Cuál es la diferencia? 1 y 3 décimos estamos hablando de gramos. Si quiero escribirlo aquí en mi valor posicional, ¿ok? Voy a poner aquí un 4. 4 y 5 décimas. Boom, ahí. Muy bien. Y aquí 3 y 2, ¿ok? Fácil. Y luego nada más tenemos que restar, ¿ok? Puedo poner eso ahí, escribirlo así, restar. Fíjense, chicos, lo importante es que mis decimales siempre están alineados, ¿ok? Quiero que presten mucha atención a eso cuando vamos siguiendo, cuando vamos haciendo más problemas hoy, vas a ver que los decimales siempre van a estar alineados, ¿ok? Vamos a ver algunas otras maneras de resolver esos problemas. Explica cómo hallar la diferencia entre las masas de los colibríes hembra y macho, ¿ok? Nosotros, o sea, ustedes pueden restar nada más fácil. Puedes usar una tabla de valor posicional, ¿sí? Puedes usar unos cuadritos, puedes usar una línea numérica. Vamos a practicar con cada una de esas maneras hoy. Y, ¿sabes qué? Si a ti te gusta más la línea numérica, excelente, puedes usar eso. Si a ti te gusta valor posicional, perfecto. Si tú nada más quieres alinear tus decimales y restar, fácil, hazlo así. Hazlo en la mejor manera para ti, ¿ok? Lo importante es que tú puedes resolver el problema. Vamos a ver, sigue adelante. Se pueden restar decimales de diferentes maneras, al igual que se pueden restar números enteros de diferentes maneras. Piensa en el problema, ¿ok? Ahora tenemos diferentes números, 2 y 98 centésimas menos 2 y 56 centésimas. Aquí tenemos una tabla de valor posicional. Vamos a llenarlo con esos números. Primero vamos a escribir el número más grande. Unidades, tenemos 2, décimas 9 y centésimas 8. Aquí 2, décimas 5. Y aquí están los números, chicos, ¿verdad? Ok. Y el 6. Boom, ahí. Ok. Listo. ¿Ahora qué? Resta dentro de cada posición. Escribe la diferencia. ¿Ok? Fíjense, chicos. Decimal, 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 decimal. Siempre en la misma posición. Eso es el clave. ¿Ok? Clave. Punto principal. Hay que alinear los decimales. ¿Ok? 8 menos 6. Fácil. 2, 9 menos 5. 4. ¿Verdad? Y 2 menos 2. 0. Entonces, a ver, ustedes dicen la respuesta que es 42 centésimas. Muy bien. Ok. También puedes hallar la diferencia usando una recta numérica, línea numérica, y una estrategia de sumar hacia adelante. ¿Ustedes han hecho eso antes? Ok. ¿Sí? ¿No? Tal vez. Ok. Vamos a ver. Tenemos una línea numérica, ¿ok? O una recta numérica, ¿ok? Y estamos empezando a 2 y 56 centésimas y vamos a intentar llegar a 2 y 98 centésimas, ¿ok? Y lo que vamos a hacer es ir contando, ¿ok? Para ver dónde terminamos. Hay que ver cómo está dividido, o sea, cuál es el espacio entre cada uno de esos espacios aquí. Entonces, si tenemos 2 y 56 centésimos aquí y 2 y 5 aquí, ¿qué cree que tenemos aquí? Tal vez 2 y 52. 2 y 50 aquí sería 2 y 54 y 2 y 56. 2 y 58, 2 y 60 décimos, ¿ok? Entonces, usando esa información, podemos ver aquí, ¿ok? Que eso es como van contando. 4 centésimos, ¿verdad? 4 centésimos. Porque yo fui de aquí, de 2 y 56 centésimos, ¿verdad? 56 a... Eso es un 0. Aquí es 2 y 60 centésimos o 2 y 6 décimas. Aquí está. ¿Ok? Entonces yo brinqué 4 centésimas. Entonces por eso tienen escrito aquí el 4 centésimos. ¿Ok? Luego voy a querer llegar aquí a 2 y 98. De 2 y 60 de aquí puedo brincar 3 décimos hasta 2 y 9 décimas o 2 y 90. Ok. Brinco 3. Aquí, 3, ¿verdad? Luego, aún no he llegado a 2 y 98, ¿verdad que no? Estoy en 2 y 90. Ok, entonces tengo, déjame, ok, tengo que brincar de 2.90 a 2.98. Voy a brincar 2, 4, 6, 8 centésimos. Aquí está, 8 centésimos, es el último brinco, ok. Ahorita vamos a sumar, ya somos expertos en sumar, ¿verdad? Este es 30, podemos escribirlo así si quieren. 0, 4, 3, voy a poner el 0 ahí, ¿verdad? Es 30 centésimos o 3 décimos. Y 0, 8, ¿ok? 4 más 8, 4. 12, ¿verdad? 2 aquí, 1 aquí, 1 más 0, 1 más 3, 4. Entonces, aquí está 42. Decimal, 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 decimal. ¿Ok? Va ahí. Entonces, mi respuesta es 42. ¿42 qué? Centésimas. ¿Ok? Ahí está. 42. Igualito, ¿verdad? O sea, es igual. ¿Cuál fue más fácil? Para mí, tabla de valor posicional. Tal vez para ti, la recta numérica. Tu decisión, chicos, tu decisión, ¿ok? Haz lo que sea más fácil para ti, ¿ok? Lo importante es que terminas con eso de 42 centésimas. Es lo importante, ¿ok? Muy bien, chicos. Vamos. Otra problemita. Marty come 2 y 5 centésimas onzas de queso de un bloque de queso cheddar de 4 y 6 décimas onzas. ¿Cuántas onzas de queso cheddar quedan? Porque Marty, aunque tuvo hambre, no comió todo el queso, ¿verdad? Comió un poquito. A ver, sabemos que es restar porque ¿cuántas quedan? ¿Verdad que sí? Eso nos está diciendo. Restar, 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 ¿ok? Entonces, ya sabemos que es restar. ¿Qué vas a hacer? Bueno, puedes usar la recta numérica. Puedes usar tu tabla de valor posicional. O puedes alinear tus decimales así y restar. ¿Ok? ¿Cómo lo vas a hacer? Pues es tu decisión, ¿ok? Fíjense, chicos, aquí es un poquito diferente si lo escribes así, no tienes nada aquí, ¿verdad? Hay que poner un 0, ¿ok? No cambia nada, no va a cambiar la respuesta, pero hay que poner ese 0, ¿ok? Vamos a ver. Ok, bueno, chicos, si ustedes quieren poner pausa y intentar resolver el problema así, ¿ya? Pon pausa, inténtalo, ¿ok? A ver si puedes hacerlo así nada más. Muy bien. Ok, ahorita vamos a ver cómo lo hacen con bloques. Ok, modelos de base 10. Empezamos con 4 enteros y 6 décimas. Ok, que representa la cantidad de queso. ¿Verdad que sí? 6 décimas es igual a 60 centésimas. Ok, aquí está. 1, 2, 3, 4. Ok. Enteros, 4 enteros y 6 décimas. 1, 2, 3, 4, 5, 6, ¿ok? ¿Y cuánto queso comió Marty? 2 enteros, entonces por eso esos están tachadas. Vamos a quitarlos. Este queso ya desapareció. Y 5 centésimas, ¿ok? Entonces, como centésimas es más pequeña que una décima, ¿ok? Hay que prestar atención a eso. Ellos fueron y quitaron 1, 2, 3, 4, 5, ¿ok? Y ahora nada más hay que contar. Ustedes pueden poner pausa y pueden empezar a contar si quieren. ¿Ok? Ustedes pueden poner pausa y pueden empezar a contar si quieren, chicos. Muy bien. Ok. No les voy a dar la respuesta aún. Ok. Vamos a ver aquí. Aquí tenemos escrito con valor posicional, más parecido a lo que decimos en al principio de empezar con ese problema. Usar una tabla de valor posicional, te ayuda a asegurarte de que los valores posicionales estén alineados de la manera correcta. ¿Ok? 4 y 6 décimas, 2 y 5 centésimas. ¿Ok? Y ahora, nada más, vamos a restarlo. ¿Ok? Aquí está. Pueden poner pausa aquí si quieren para restar. Vamos a contestar unas preguntas. Si te fijas, yo no te he dado la respuesta todavía, ¿verdad que no? Vamos a ver. Mira los modelos de base 10. Explica por qué hay partes de los modelos que están tachadas. ¿Por qué? Si vemos aquí, ¿por qué están tachadas? Pues Marty comió ese queso, ¿verdad? Estamos restando esa cantidad. Entonces, por eso lo tenemos que tachar, ¿verdad que sí? ¿Cuántas onzas de queso quedan? Vamos a ver. 1, 2, ¿verdad? 2 onzas aquí. 1 y 2. Entonces podemos decir que 2 y 1, 2, 3, 4, 5. ¿Ok? ¿Por qué 5? Porque tenemos 5 décimas completas y luego aquí tenemos 1, 2, 3, 4, 5 centésimas. Entonces tenemos 2 y 55. ¿Ok, chicos? Muy bien. Y si seguimos a resolver ese problema, vamos a tener lo mismo. Aquí tú puedes ver, puedes poner pausa ahorita para terminar con esa lección para ver cómo lo hicieron. Tienes que prestar del 6, uno de 6 para que sea 10. Y aquí también vas a terminar con la misma respuesta, chicos. Pon pausa aquí si te queda una duda. ¿Ok? Ya puedes usar una recta numérica, puedes usar modelo de base 10, puedes usar una tabla de valor posicional y espero que ustedes pueden hacerlo así también. ¿Ok? Bueno, chicos, hasta luego. Que les vaya bien. Mucho gusto por su atención. Adiós.